So, good afternoon, everybody. Myself, Acharya Vishvendra. Let's discuss a worksheet on calorimetry. So, here is the worksheet. So, the first question is 100 gram of ice is at 0 degree centigrade. Then we need to find minimum mass of water at 80 degrees centigrade to completely melt ice. So, here we calculate the amount of heat required to melt ice, which is given by m into L, so which is 100 into 80. And we suppose that the mass is m naught, so the heat supplied by the water will be m naught 1 into 80. As we have calculated the minimum mass, so we assume that the final temperature is 0, so that there is no extra heat left, so that will give the minimum value. So from here the calculations gives m naught is equal to 100 gram. Then is the next question, if mass of water is m naught by 3. So obviously if mass is less than the minimum mass, so complete ice will not melt. That means final temperature will be 0 degree. Next is equilibrium composition if mass of water is m naught by 3. So here we calculate that final temperature is 0, so complete ice has not melt. So we calculate the amount of ice melt, which is given by this expression. Suppose m dash ice melt, so heat required will be m dash into 80, and heat supplied by water will be m naught by 3 into 1 into 80. So from calculations m naught comes out to be 100 by 3. So that means finally 100 by 3 ice will melt, so that will give water. So the total mass of water is m naught by 3, which is formed by melting of ice, and m naught by 3, which is due to the water present. So the total will be 2 by 3 m naught, which is 200 by 3 gram, and mass of ice left will be m naught minus m naught by 3. After calculations it comes out to be 200 by 3 gram. Next is equilibrium temperature if mass of water is twice of m naught. So since mass is greater than m naught, that means final temperature will be greater than T. So complete ice will melt. So we calculate the heat required for the temperature to raise through, let's say assume that the final temperature is T. So comparing for ice, this energy will be needed for melting it, plus ms delta T, that will be heat required to increase temperature by T. So total heat absorbed by ice will be this. Now we calculate the heat supplied by water, which will be 200 into 1 into 80 minus T. And after all the calculations, T comes out to be 80 by 3, which is 26.6 degrees centigrade. Next is we need to find equilibrium composition in this case. So obviously ice will melt completely and temperature is 26.6. So complete transfer will be the water itself. And here ice will be 0 gram. Next is equilibrium composition if mass is m naught. So here also ice will be 0 and water will be completely m naught plus m naught, which is 200 gram in this case. Next question is 200 gram water at 10 degree is given, then find minimum mass of steam at 100 to increase temperature to 90. So we calculate the heat required, which is ms delta T, and suppose m naught mass of steam is needed, so the heat given by ice will be m naught by steam will be m naught into 540 due to condensation, plus m naught into 10 due to degrees of temperature from 100 to 90. So after calculations we get m naught as 29 gram approximately. Then is final temperature if ms is twice of m naught. So obviously if steam is greater than mass is greater than the minimum value, so the final temperature we need to calculate is that the heat required to increase temperature up to 100 is 18,000 calorie, and if we assume that all the steam will condense, it will give a heat of 31320 calorie. Obviously this is greater than 18,000, which means that full steam will not be needed to condense. So a part of steam will be capable to carry out water to increase temperature of water to 100. So the final temperature will be 100 degrees centigrade. Next is final composition if m1 mass of steam is 2 m naught. So we assume that m mass of steam condense. So after calculations m comes out to be 33.3 gram. So water will be 200 plus 33.3, which is 233.3 gram, and steam left will be 58 minus 32.3 gram, so which is 24.7 gram. Next is final temperature if m is equal to m naught by 2. So in this case, let's calculate that whether this heat is able to convert water at 290 or not. So in that case, the first thing is just calculate the temperature. So we assume that final temperature is T. So water will absorb heat 200 into T minus 10, and the condensed stream will give heat 14.5 into 540 plus 100 minus T. So after calculations, T comes out to be 52.58 degrees centigrade. Now we need to find the composition. So water will be 200 gram plus, due to condensed steam which is 14.5 grams, so 214.5, and steam, so there will be no steam left as the temperature is 52.58, so mass of steam will be 0. Next is, if M is equal to M naught, then water will be water will be at 90 degrees, so there will be no steam left and entire mass will be converted into water. Next is 40 gram of ice is at 0 degree. We need to find final temperature if 6 gram of steam is mixed with it. So we calculate the amount of heat available from the steam, which is 3840 calorie, and to melt ice completely the heat required is also 3840. So that means final temperature will be 0. Next is final composition of mixture in the above case. So here water will be 48 plus 6, as entire composition will be in liquid state, water state, ice 0, steam 0. Next is find final temperature if 16 gram steam is used. So first of all, let's calculate the amount of heat required to increase temperature of ice to 100. So it comes out to be 8640 calorie. And on reverse calculation, let's check the amount of heat available from condensation of steam. So that also comes out to be 8640. So the two energies are equal, that means final temperature will be 100. Next is final composition in above case. So entirely water will be present, no steam and no ice. Next is final temperature if 20 gram steam is used. So if we calculate using 20, it comes out to be 10,800 calorie, which is greater than 8640 calories. So the final temperature will be 100 and a part of steam will be condensed, not entirely. So using that, we need to find final composition in the above question. So we suppose that M mass of steam condenses, it gives energy 8640. So after calculations, we get that as 16 gram. So water will be 48 plus 16, which is 64 gram. So steam will be 4 gram.